geometry. Clear? Okay. So in this we shall discuss how you are going to use the complex numbers in coordinate geometry. For that, first let us take distance formula, that is distance formula. That means distance between two complex numbers. Suppose if P of Z1 and Q of Z2 are the two complex numbers, then distance between P and Q is mod of PQ equal to mod of Z2 minus Z1. Clear, students? That means if P of Z1 and Q of Z2 are the 2 points in the complex plane, clear, this is P of Z1 and this is P of Z2, the distance between P of Z1 and P of Z2 is given by mod of Z2 minus mod of Z1. So here you must know one note, that is mod of Z equal to distance of point in complex plane from origin. So that means the distance between 2 points in complex plane is given by mod of Z2 minus Z1. Clear, students? Already you know what is mod of Z2 minus Z1? Square root of x2 minus x1 whole square plus y2 minus y1 whole square will be your mod of Z2 minus Z1, because your Z1 will be x1 plus I y1 and Z2 will be x2 plus I y2. So if you want to calculate the distance of P to Q, you are going to calculate mod of Z2 minus Z1. What is the meaning of mod of Z2 minus Z1? See, Z1 is x1 plus I1, Z2 is x2 plus I2, so x2 plus I y2. So therefore, if you want to calculate the distance between Z1 and Z2, x2 minus x1 whole square plus y2 minus y1 whole square will be the distance between two complex numbers in complex plane. So that is, whenever you are going to calculate mod Z, only mod Z, not mod Z2 minus Z1, if you want to calculate mod Z, that will be the distance of that particular complex number from origin. That means mod Z is nothing but the distance of complex number from origin. Clear, students? Now let us move for the second one, that is section formula. Clear? Now let us go for the second one, that is section formula. So in the section formula, let P of Z1, Q of Z2 be the 2 points and this be the line joining PQ. Here let us take R of Z, which is dividing this line segment in the ratio M1 is to M2. Clear, students? So here this is Z1, this is Z2. R of Z is dividing in the ratio M1 is to M2. That means if P of Z1 and Q of Z2 be the 2 points for line segment PQ joining the points Z1 and Z2, where Z1 and Z2 are two complex numbers. So now, if Z1 and Z2 are two complex numbers, the section formula tells that first one is internally it is equal to M1 Z2 plus M2 Z1 divided by M1 plus M2. So internally the formula will be M1 Z2 plus M2 Z1 divided by M1 plus M2. And the second one will be externally, that is equal to M1 Z2 minus M2 Z1 divided by M1 minus M2. So if the line segment is joining the 2 points PQ in the complex plane, internally it will be M1 Z2 plus M2 Z1 divided by M1 plus M2. Externally it will be M1 Z2 minus M2 Z1 divided by M1 plus M2. So suppose it is midpoint. Note for midpoint it will be Z1 plus Z2 divided by 2. For the midpoint it will be Z1 plus Z2 divided by 2. So these things are going to be very easy if you are perfect with the section formula of straight line from the topics of straight line on real number plane or real plane. But in this complex plane, here you are going to just have the changes in Z1 and Z2. There you are going to write X1 and X2. Clear? Here you are going to write Z1 and Z2. Clear, students? So if you are very much perfect with the section formulas on the real plane, these particular things are going to be very easy to you all. Clear? So please remember that internally it will be M1 Z2 plus M2 Z1 divided by M1 plus M2. Externally it will be M1 Z2 minus M2 Z1 divided by M1 plus M2, and the midpoint will be Z1 plus Z2 divided by 2. So this is what the section formula of your complex plane and the line drawn on the complex plane. Okay, students? For the third one, that is equation of perpendicular bisector. Clear, students? So first you must know what is the perpendicular bisector. Clear? So first let us know what is perpendicular bisector, then let us go for the equation of perpendicular bisector. Clear? Okay. Here P of Z1 and Q of Z2 be the 2 points and the line segment joining PQ. This is the line segment joining PQ. Clear, students? So now the perpendicular bisector will be the locus of the line R of Z. That means the locus of the point R of Z. You call it as locus or you call it as the path of the point RZ. The path of the point RZ is always having the equal length from PR to QR. Are you getting my point? So the path of the RZ will be such that it is always with equidistant from P and Q. It is always equidistant from P and Q. Then we say the path drawn from RZ will be the perpendicular bisector of the line PQ. Are you getting my point? Clear? The perpendicular bisector is the path of the line drawn by the point R of Z, which is always equidistant from P and Q. That means it should be always perpendicular to the P and it should be always perpendicular to the Q for being an equidistant from Q, because if it has to be an equidistant means it should be a perpendicular to both P and Q, so that it is going to have the same path by R of Z, that is drawn by the dotted line. So this dotted line is going to be the perpendicular bisector of PQ. Are you clear, students? So now let us draw the equation, that is, see here, the distance of RP is equal to the distance of RQ, or you can write it as the distance of PR or the distance of QR. So now this will be equal to Z minus Z1 equal to mod of Z minus Z2 mod of Z minus Z2. Clear, students? So the length of RP is equal to the length of RQ. That is what the definition tells from the perpendicular equation of bisector. Clear? So from that we say that RP mod of RP is equal to mod of RQ. Z minus Z1 mod of Z minus Z1 will be equal to mod of Z minus Z2. So now if I want to solve the equation, I will make squaring on both sides. Now it will be Z into Z2 bar minus Z1 bar plus Z bar equal to Z2 minus Z1, that is equal to mod of Z1 square minus mod of Z2 square. So this is going to be the equation of perpendicular bisector. Clear? This is going to be the equation of perpendicular bisector, that is R of Z. Perpendicular bisector, that is R of Z to the line segment PQ. To the line segment PQ. Okay, students? So this is what your equation of perpendicular bisector. In this, while solving by squaring on both sides, directly I have written the result. It has 2, 3, 4 steps to simplify Z minus Z1 whole square equal to Z minus Z2 whole square. It has 2 to 3 steps where you have to simplify. So what I have done, I have written directly the equation is what. If you want to make the solution of this, you can make a solution of this, no problem. Clear? By using the formula of Z bar equal to Z into mod of Z square equal to Z into Z bar. By using this formula, you can simplify this particular equation and you can write the result. So there will be no problem. Clear? But here I have written directly the equation of perpendicular bisector. Please don't get confused. Okay, students. Now let us go for the equation of straight line. That is, a straight line equation of line joining Z1 and Z2. Equation of line joining Z1 and Z2. First will be parametric form. First one will be parametric form, that is Z1 into T plus Z2 into 1 minus t equal to 0. Clear, students? Z1 into t plus Z2 into 1 minus t equal to 0 will be the parametric form of straight line. Clear? Here the equation of line joining Z1 and Z2 will be, that is in the parametric form, Z1t plus Z2 1 minus t equal to Z. Clear, students? Z1t plus Z2 1 minus t equal to Z will be your parametric form. Here t belongs to real number set. Please remember that t is a real number. Z1 and Z2 are the complex number. So the parametric form of a straight line in the complex plane will be Z1 of t plus Z2 of 1 minus t equal to Z, where t belongs to real number set. Next, second one, non-parametric form. Non-parametric form equal to determinant of Z, Z bar 1, Z1, Z1 bar 1, Z2, Z2 bar 1 will be equal to 0. Clear, students? So non-parametric form of a straight line joining the two complex numbers Z1 and Z2 will be Z, Z bar 1, Z1, Z1 bar 1, Z2, Z2 bar 1. The determinant must be equal to 0. So if this type of equation, if you solve, it will be what? It will be Z into Z1 bar minus Z2 bar minus Z bar into Z1 minus Z2 plus 1 into Z1 into Z2 bar, Z1 into Z2 bar minus Z2 into Z1 bar. That will be equal to 0. Clear, students? So Z into Z1 bar minus Z2 bar minus Z bar into Z1 minus Z2 plus Z1 into Z2 bar minus Z2 into Z1 bar will be the equation of straight line in the complex plane where Z1 and Z2 are present. So that determinant must be equal to 0. Z, Z bar 1, Z1, Z1 bar 1, Z2, Z2 bar 1. So that determinant must be equal to 0 for non-parametric form. Then, okay, for coplanarity I will discuss here. So now, in the fifth point, let us discuss the coplanarity of the line with 3 points. That is coplanarity condition. Coplanarity condition with 3 points. Clear? Coplanarity condition with 3 points in the complex plane. That is point A, point C and point B are on the same line. Now I want to show that these 3 points are coplanar. Then what is the condition for showing A, B, C are coplanar? Means that is determinant of Z1, Z1 bar 1, Z2, Z2 bar 1, Z3, Z3 bar 1 must be equal to 0. Please remember here Z1 equal to x1 plus I y1, Z2, Z1 bar will be equal to x1 minus I y1. That means if Z1 is complex number, Z1 bar is conjugate of complex number. Z2 is complex number, Z2 bar is conjugate of Z2. Clear? So now, if I want to show that points A, B, C, that is Z1, Z2, Z3. Point A is Z1, A of Z1, B of Z2, C of Z3 are going to be the coplanar if the determinant of Z1, Z1 bar 1, Z2, Z2 bar 1, Z3, Z3 bar 1 is equal to 0. Clear, students? So, if you simplify this equal to 0, then I can say that Z1, Z2, Z3 are coplanar points which are on the same line in complex plane. So now slope of AB must be equal to slope of BC, and that must be equal to slope of AC for coplanarity. Clear, students? So for that reason, slope of AB is Z2 minus Z1 divided by Z2 bar minus Z1 bar. Next, this will be equal to slope of BC, that is Z3 minus Z2 divided by Z3 bar minus Z2 bar. Next, slope of AC will be equal to Z3 minus Z1 divided by Z3 bar minus Z1 bar. So, this is going to be the slope of AB, the slope of BC and the slope of AC. So, in these two conditions, you can prove of any kind, no problem. In these two, that is determinant of Z1, Z1 bar 1, Z2, Z2 bar 1, Z3, Z3 bar 1 is equal to 0. Either you prove this as equal to 0 or you prove slope of AB equal to slope of BC equal to slope of AC. If you show this, this will be the condition for coplanarity of 3 points in the complex plane, or if you show this determinant is equal to 0, again that will be the condition for coplanarity of 3 points in the complex plane. So by using these all conditions, you can show that the coplanarity of 3 points is given by what? Clear? So if you want to show the coplanarity, you please remember these two conditions in complex plane. Okay, students. Now here let us see at what is the general equation of straight line. What is general equation of straight line? So for that reason, general equation of line is given by a bar z plus a z bar plus b equal to 0. So please observe here a bar and a and z belongs to complex. A and z belong to complex. B belongs to real. That means the general equation of the straight line is given by a bar z plus a z bar plus b equal to 0. Here a and z belongs to complex numbers, b belongs to real numbers. Clear, students? Okay. From the general equation of line, we know that a and z are complex, b is real number. So please remember that the general equation of line is given by a bar z plus a z bar plus b equal to 0. Now slope of complex equal to, this is minus a by a bar. Are you clear, students? Slope of the complex is equal to minus a divided by a bar. Next, slope of real is equal to minus of real part of A divided by imaginary part of A. Clear? Slope of real is given by minus of real part of A divided by imaginary part of A. And this also can be written as I into A plus A bar divided by A minus A bar. Clear, students? So real part divided by imaginary part of A or equal to I times of A plus A bar divided by A minus A bar will be the slope of real for the general form of line, or the complex plane will be minus A divided by A bar for the general equation of straight line. So be clear with this. General form, the equation of line joining 2 points in parametric form, equation of straight line in non-parametric form, the condition for coplanarity of the straight line, and the general equation of a straight line, that is A bar z plus z A z bar plus b equal to 0. The slope of the complex from the general is minus A divided by A bar, and the real plane, the real slope will be minus of real part of A divided by imaginary part of A, or that is equal to I times of A plus A bar divided by A minus A bar. So please remember all these terms without neglecting, because these particular terms are going to be very important for your exams. Okay students, now let us discuss the 8th point, that is the perpendicular distance of the complex number from the general equation of line. That means if Z1 is a point, then the perpendicular distance from your line A bar z plus A z bar plus b equal to 0 is what? That I will discuss here. Clear? So this is the general equation of line. You have one point Z1. Now you want to calculate the perpendicular distance. That means suppose this is the line given by A bar z plus A z bar plus b equal to 0. The perpendicular distance of Z1 from the line L, from this line, let us find. It will be mod of A bar Z1 plus A Z1 bar plus b divided by mod of A plus mod of A bar. So that also can be written as mod of A bar Z1 plus A Z1 bar plus b divided by 2 times of mod A. 2 times of mod A. So these terms are going to be very important. Clear students? 8th point is the perpendicular distance of a line. How to find in complex plane? The line will be A bar z plus A z bar plus b equal to 0, where z and A are the complex numbers, the b is real number. Now I want to find the perpendicular distance of Z1. The perpendicular distance of Z1 from this line L, that is A bar z plus z bar A plus b equal to 0. So from this line, what is the perpendicular distance of Z1? That is mod of A bar Z1 plus A Z1 bar plus b divided by 2 times of mod A. Again, these particular terms are going to be very easy for you if you know the perpendicular distance of straight line from your 11th class. Clear? See, if you know the properties of straight line, if you know the distance, perpendicular distance of a straight line, if you know the slope of the straight line, if you know the equation of a straight line in the real plane, it will be very easy to remember all these 8 points which I have discussed till now. Clear, students? So make sure that you are going to be perfect with this all terms. Now I will go for the next topic. Okay, students. Now let us go for the equation of circle. Clear, students? So for that reason, let us take P of Z naught be the center of the circle, and if I take a circle with Q of Z1 is on circle, that means now we want to solve the equation of this particular circle. Clear, students? So now if I join these two, it will be the radius R. See, P of Z0 is the center of the circle, Q of Z1 is the point on the locus of the circle. Now let us find the equation of this circle. The equation of this circle will be mod of Z2 minus Z1 equal to R. Mod of Z0 minus Z1 will be equal to, it can be also written as mod of Z1 minus Z0 will be equal to R. No problem. Clear, students? So the equation of circle is either mod of Z1 minus Z0 equal to R, or mod of Z0 minus Z1 will be equal to R, where R is the radius of the circle. R is the radius of the circle. Suppose if I write mod Z equal to R, mod Z equal to R, the center will be origin. Clear, students? If I write mod Z equal to R, the center of the circle will be at origin. So that is what your first special case. Clear? Second one is mod of Z minus, Z0 minus Z1 lesser than R indicates interior of circle. Next, third one, mod of Z0 minus Z1 greater than R is exterior of circle. Exterior of circle. That means the equation of circle is mod of Z0 minus Z1 equal to R. Otherwise you can write it as mod of Z1 minus Z0 equal to R. So now if this is the equation of the circle, you have three special cases. First one is mod Z equal to R means the circle having center at origin. If you write like this, mod of Z0 minus Z1 is lesser than R, it is interior of the circle. If you write mod of Z0 minus Z1 is greater than R, it tells that it is exterior of the circle. Clear, students? So please remember the equation of the circle is mod of Z equal to R. And these three special cases. Now radius. Radius will be equal to square root of your mod A square minus B. Mod A square minus B. So now you may get where is A and where is B. Where is A and where is B means the general equation of straight line is equal to, that is Z bar plus A Z bar plus A bar Z plus B equal to 0. So this is the general equation of line, and this will, general equation of circle. So this term, that is general equation of circle, is going to be Z bar plus A Z bar plus A bar Z plus B equal to 0. So from this you can find the radius of the circle, that is mod a square minus b will be your radius and minus a will be center. Minus a will be center of the circle whenever the equation of circle is given in general form. Clear, students? The general equation of circle is z bar plus a z bar plus a bar z plus b equal to 0. So now from this you can write the radius as square root of mod a square minus b, and the center is, and minus a will be the center, or minus a will be the center, and the radius will be square root of mod a square minus b. So make sure that the equation of circle is mod of z1 minus z0 minus z1 equal to r. If r is radius, z0 is the center, z1 is the point on the circle is given. Suppose those terms are not given, then the equation of general equation of a circle will be z bar plus a bar z plus b equal to 0, and these two terms are going to be the radius and the center of the circle whenever it is in the form of general. Suppose z0 and z1 are given, then it is no problem. You can write mod of z0 minus z1 equal to r will be the circle. Clear, students? Okay, students. So now let us try to solve the problems on the topics which we have discussed now, that is the geometry of your complex plane. Clear? We have discussed the straight line equation in general form, the straight line equation in parametric form, straight line equation in non-parametric form, the length of two complex numbers, that means the distance between two complex numbers. We also discussed the equation of circle. We also discussed the general equation of circle. We discussed radius of the circle and all terms. Clear, students? So now, by using all those terms, which type of questions are going to be asked in your exam? That type of questions let us discuss here. Clear? So see, the length of line segment joining the points these two. That means what they are asking? They are asking straightforwardly that what is the length of the line segment joining these 2 points. That means you have to calculate the distance of PQ. That means the magnitude of PQ. Let us take this is P and let us take this is Q. That means here they are asking the distance of PQ. So for that reason, let us solve it by, as we all know, mod of Z2 minus Z1. That means the length of Z2 minus Z1. Z2 minus Z1 means what? 2 minus of minus 1 is 3. So that will be square root of 2 minus of minus 1 will be 3. 3 square will be 9. Plus, next again 3 minus of minus 1 will be 4. 4 square will be 16. So this will be square root of 25 and the answer will be 5. Very simple question. Okay, students? That means they are checking, do you know the formula of solving the distance between two complex numbers or not? Very, very simple problem. Now, so by this we can say that the mod of PQ, but you must know how to find the distance between PQ, because here A plus IB form, C plus ID form. So in the form of A plus IB and C plus ID, you must know how to subtract two complex numbers. The real part and the real part, imaginary part and the imaginary part has to be subtracted if you want to calculate Z2 minus Z1. And by the formula of magnitude, you can say that x2 minus x1 whole square plus y2 minus y1 whole square. Clear, students? It is as similar as your real plane. Clear? In real plane also what you are doing? You are calculating ax1 plus by1 plus c equal to 0, ax2 plus by2 plus c ax2 plus by2 plus c2 equal to 0. There also you are using square root of x2 minus x1 whole square plus y2 minus y1 whole square. Here also the same thing. You have to solve it by again x2 minus x1 whole square plus y2 minus y1 whole square. Clear, students? So from this we get that answer is 5. In real plane, what they will do? minus 1, 2, 3. So this is 0.1, this is 0.2, or I can take A, B. What is the distance between A, B? You can solve it like this also. It will be converted to your real plane. That means square root of x2 minus x1 whole square plus y2 minus y1 whole square. There it will be also very simple. Here also it will be same as it is. No other changes. But here Z2 and Z1, they are the notation of complex numbers. So please be perfect in solving the difference between two complex numbers. Okay students, see, now let us solve the second one, that is P, O and Q be the straight line passing through the origin OPQ. Clear? So that means there is a line passing through the origin OPQ in complex plane. Then it is also given that A plus IB and C plus ID are the 2 points through which the line is joining, such that OP equal to OQ. That means, see here students, this is P, this is Q, the line is passing through the origin. The line is passing through the origin. They are telling that OP and OQ are equal. These two lengths are equal, and now what they are asking, then mod of A plus IB equal to mod of C plus ID, A plus C equal to B plus D, or argument of A plus ID equal to argument of C plus ID, or none of these. Okay students, see here, it depends on solving the problem here. Clear? See, OP, this is A plus IB, CD, that is C plus ID. That means OP is A plus IB and OQ is C plus ID. You have to observe very carefully, my dear students. That means A plus IB, C plus ID are on the same line. That means a line joining from the point to P to Q. A line joining from point P to Q. That means argument of A plus IB and the argument of C plus ID. That means the slope of A plus IB, the slope of C plus ID, both are going to be the same because they are on the same line. If I see this construction, from this construction you can see that P and Q both are on the same line. Here O is the origin, line is passing through the origin with the points P, O, Q, where O is origin. Now you have two points, that is two lines, that is OP and OQ. OP and OQ, clear students? O to P, O to Q. You are having two complex lines. Clear? That two complex lines is given by, or two complex numbers is given by A plus IB and C plus ID. That means this is the point P and this is the point Q. Clear students? See, origin O is same for Q also, origin O is same for P also. That is, they are mentioning OP and OQ are of same lengths. That means they are on the same line. That means if they are on the same line, they must have the same argument also. Clear students? So for that reason, if I say argument means argument of OP, I has to say argument of OP, but argument of OP is different. That means the angle made by the line OP is different. Here the complex number is different. See what they have given, argument of A plus IB. That means argument made by this particular complex number they are asking. Are you getting my point? Again, argument of c plus id. This is the angle made by, this is the angle of c plus id, which is the argument of q. Clear, students? If OQ, the line segment angle is same, but a plus ib, the angle made by the complex number is not same. Are you getting my point, students? So for that reason, this will be not your answer. So now see here, OP, OQ are in opposite direction. OP and OQ are in opposite direction with same lengths. That means it will be minus OQ, minus of OQ. So that is vector OP and vector OQ are in opposite direction. That means it will be with the negative. Clear? Here, because of magnitude of OP vector will be equal to magnitude of OQ vector, because both are same. They have given OP equal to OQ. If I take OP vector and OQ vector, they are having the same magnitude but in the opposite direction. So now it will be OP equal to minus of OQ. If I bring this on LHS, OP vector plus OQ vector will be equal to 0. So here what is OP vector? OP vector is A plus IB. A plus IB, C plus ID. If I add those two, A plus C plus I times of B plus D will be equal to 0. That means the complex number is 0 whenever the real part and the complex part both are equal to 0. That means A plus C equal to 0, B plus D is also equal to 0. Clear, students? That means A plus C equal to 0, B plus D equal to 0. Therefore, I can say that these two numbers are equal. A plus C equal to B plus D. So option B will be your answer. Make sure that the slope of these lines are going to be the same, but not the argument of complex number. Argument of complex number P and argument of complex number Q. Are you getting my point, students? So now, after this, see, OP and OQ both are same. They have given OP and OQ both are same, means the magnitude of OP and the magnitude of OQ is again same. That means the length is same. I will represent it in vector form, OP vector and OQ vector. See, O to P, O to Q, they are in opposite direction with the same magnitude. They are the opposite direction in the same magnitude. That means vector OP equal to minus of vector OQ. If I bring minus of vector OQ on this side, it will be OP plus OQ. So if I add those two, you will get A plus C plus I times of B plus D equal to 0. That means A plus C is equal to 0, B plus D is also equal to 0. On the same way, see here, magnitude of OP means what? That is mod of A plus IB. Magnitude of OQ means what? Mod of C plus ID. These terms are also going to be the same. That means you have two options as correct answers, because magnitude of OP is what? Magnitude of A plus IB. Magnitude of OQ is what? Magnitude of C plus ID. So this will be also your answer, and second option will be also your answer. You have more than one option as correct in this particular question, which will be asked in your advanced exams. Are you getting my point? So in advanced exams, you are going to have more than one option going to be the correct. In that situations, so these two will be your answers, because here OP is equal to OQ. That means OP is A plus IB, C plus ID, OQ. So if I represent them in a vector form and if I simplify, you are going to have A plus C equal to B plus D. So option A and option B is your answer. Okay, students. Here, let us go for the next question. That is, the equation of circle is given. The equation of circle is given. Then what is radius they are asking? First you have to see the equation of circle is in which form. Students, you have to observe that the equation of circle is in which form? See, it is in the form of z into z bar plus a into z bar plus a bar into z plus b equal to 0. That means general form. It is in the form of general. So the general equation of straight line is given. Then what they are asking? They are asking what is radius. Clear, students? So what is radius here? As we all know, radius is equal to square root of mod of a square plus mod of a square minus b. Clear, students? So mod of a square means a value is what? 2 plus 3i. Mod of a square means that is square root of what? Again here square root of 2 square plus 3 square. 2 square plus 3 square is how much? 9. 9 plus 4, that is okay. Mod of a square. Okay. Mod of a square, that is 2, 4, 9. 9 plus 4, 13. Minus b is 4. Clear? So root of 13 square, because this is mod a square. That means root 13 square. Root 13 square means 13. 13 minus 4 will be root 9, and that will be equal to 3. So make sure that mod a means square root of a square plus b square, or square root of 2 square plus 3 square. Square root of 2 square plus 3 square will be what? Square root of 13, and mod a square tells that it will be only 13. 13 minus 4 will be 9. Square root of 9 will be 3. So therefore option B will be your correct answer. Clear, students? See, on the basis of the geometry of complex numbers, how they are going to ask the question, because this is also one of the important topic. Definitely they may ask the questions from the geometry of complex numbers. Clear, students? So for that reason, make sure that in complex numbers and quadratic equations, combining these two, definitely there will be 2 questions from both the concepts. That means complex number 1 question, quadratic equation 1 question. Clear? So from both of these concepts, one problem will be there. So you have to go through all the concept with clarity. Clear? Don't just see it once, or don't just see whenever you want. Clear? You have to solve more and more problems. You have to get more and more concept clarifications of that particular topics, and you have to solve. So be sure that definitely every year complex number 1 question, quadratic equation 1 question will be there in your mains exam. Clear, students? So for that reason, don't neglect complex number and quadratic equation, and don't feel quadratic equation and complex numbers are very easy. Why I am explaining this? Because in this topic I have solved so many concepts on complex numbers and so many concepts on quadratic equations. So for that reason I am telling, complex numbers there will be 1 question, quadratic equation there will be 1 question. So you just guess, definitely there will be like that. If comes, you are lucky. If not comes, there will be definitely 1 question either from complex or from quadratic. No issue. If you come with 2 questions, then it is more and more good. Clear? But definitely minimum 1 question, maximum 2 questions. Clear, students? So minimum 1 question is fixed for either it may be of complex or it may be of quadratic, or sometimes they will ask 1 question from complex and 1 question from quadratic. This is what the pattern of this particular topics. Clear, students? So now you got the idea of geometry of complex numbers. So solve more and more problems on every topic which I have discussed. Thank you.